The next technique to find the rank of the matrix. The method name is normal form or canonical form. A matrix capital A equal to Aij of order m by n is said to be in normal form or canonical form if A can be reduced into the form of IR000 or IR0 or column wise IR0. Once again, normal form or canonical form, a matrix capital A equal to Aij of order n by n is said to be in normal form if A can be converted into identity matrix. Identity matrix means IR000. This is square matrix. Now row wise IR0 or IR0 column wise. Now A can be converted into these forms. Then rank of the matrix A is R, because we are getting identity matrix of order R by R. IR is nothing but of order R by R. Now this is nothing but normal form. The technique. Now how to convert into the normal form, how to convert into identity form. In this we can use column operations and row operations, but you have to use systematically. Now I will explain how to use those row operations and column operations. Any matrix can be converted into normal form. Now the general matrix I have taken. Observe this one. Again I am taking here 4 by 4 matrix. If it is 4 by 5 also you can convert it. Every time I am taking square matrix only, big matrix. 4 by 4 matrix. First row containing 4 elements with into symbols like this. 1, 2, 3, 4. In the second row again 4 elements. In the third row 4 elements. In the fourth row also 4 elements. Now if you want to convert this matrix into identity matrix by using row and column operations, means again you should use principal diagonal elements. Now I am using first principal diagonal element A11, means the position of the first row first column element. Using that element you make below elements as zeros like this. I kept arrow mark 1, 2, 3. While converting these into 0, then you should use row operations, only row operations. Using that element, R2 changes as R2 minus something, R3 changes as R3 minus something, like that. Means using the first principal diagonal element, make below elements as zeros. Again, this is the first step. Next step, using the same first principal diagonal element, make side elements as zeros. Side elements using 1, 2, 3. While making these as zeros, you have to use column operations. Only column operations. This is the first step and second step. The first step containing row operations and column operations. Next, come to the using the second principal diagonal element. Using that element, again below elements as zeros, row operations, side elements as zeros, column operations. Again, third diagonal element, below and side elements. Like this you have to follow systematically. Then if you are following these type of steps, then automatically the matrix converted into identity form. After getting identity matrix, while converting, we may get identity matrix of order 3 by 3, of order 4 by 4, of order 2 by 2. If it is 3 by 3, rank of A is 3. If it is 4 by 4, rank is 4. Like that you have to follow. Now this is nothing but normal form. Next, finding the inverse of non-singular matrix. Finding the inverse of non-singular matrix means whose determinant is not 0. This method is nothing but Gauss Jordan, by Gauss Jordan. Now first step, A is a given matrix of order n by n. A is a given matrix of order n by n, means a square matrix, non-singular square matrix, means n rows and n columns. Second step, the matrix A can be written as A equal to, I am writing here, A equal to of order n by n equals to, again I am writing matrix I n by n into just A I am writing, I am not writing matrix symbol. When I am writing matrix symbol, you have to understand, you should write that matrix with elements. When I am writing just letter A, means you have to understand, no need to write, means we are not doing anything on that matrix. We are not applying any row or column operations. This is the important. Once again, the matrix A can be written as in square bracket A of order n by n equals to identity matrix of order n by n into capital A. Now, after completion of this one, the I n by n is called prefactor matrix. Now, that expression, once again I am writing into the form of matrix. A can be written as, I have taken A11, A11, A12, A13. First row is over. 3 by 3 matrix I have taken. A21, A22, A23. Next row, A31, A32, A33. Second. Third row is over. Equals to identity matrix of order 3 by 3. If it is n by n, identity matrix are also n by n. Means I have taken 3 by 3. This is also 3 by 3 matrix. 1, 0, 0, 0, 1, 0. Second row is over. Third row, 0, 0, 1. Now, into, I am not writing matrix, just letter A. Means that A is everywhere like that. Now, convert this matrix, convert that LHS matrix into identity form, into identity matrix by using only row operations. This is because this is Gauss-Jordan method. Once again, convert LHS matrix into into the form of identity matrix by using row operations only. Means again, whatever you are applying row operations on that matrix A, apply the same row operations on prefactor matrix also at a time. If you are using row operations on A, again use the same row operations on prefactor matrix. Then the LHS matrix converted into identity form, that identity matrix converted into another matrix, into the form of another matrix. Means at last we will get I equal to LHS side I equal to B into another matrix. I will treat that whatever you are getting new matrix, I will treat as B into A. Means I equal to B into A means B is the inverse of A and A is the inverse of B. Therefore, B is the inverse of the given matrix A. You write that answer. The technique, how to convert this, how to apply these row operations. Once again, I am explaining the technique. You take that 3 by 3 matrix, LHS side or whatever we have taken, that matrix I am taking here. A11, A12, A13, A21, A22, A23. Third row, A31, A32, A33. Again, every time using principal diagonal elements. First principal diagonal element, make below elements as zeros. Using first principal diagonal element, make below elements as zeros using row operations. R2 changes as R2 minus something like that. You have to do some calculation. Again, using second principal diagonal element, above element is 0, you make above element as 0 and below element as 0. This is one. Next, third one. Third diagonal element. Using the third diagonal element, make above elements as zeros using row operation. This is nothing but Gauss-Jordan method. This is the technique.